All right, y'all. Today I'm going to be talking about evaluating polynomials. So polynomials is just a really fancy way to describe a function that has more than one term. So a function with more than one term. Okay. So anytime I talk about a polynomial, it's just a function. So a function is something that involves an independent variable x and a dependent variable y. So to evaluate a function, so a function is something like f of x. Okay, so we're evaluating functions. To evaluate a function at a specified value of x, we are going to replace all x's in the function with the specified value that we're evaluating at. So let's look at example 1. So example 1, I have f of x is equal to 4x minus 1, and I want to evaluate it at x equals 5. So f of 5 is equal to 4 times 5 minus 1. So I've just replaced the x with the value that I'm trying to evaluate at, the specified value. After I do that, we're going to simplify the function to get f of x equals some value. Okay, so we're going to simplify until we get this f of whatever by itself. So before I can subtract the 1, I have to follow my PEMDAS, so parentheses, exponents, then multiplication. So 4 times 5 is 20. So f of 5 is equal to 20 minus 1, and 20 minus 1 is equal to 19. Okay, so since I got f of 5 by itself, and I have 19 by itself, I'm done. Okay, and remember, just as kind of a recap from earlier in the year, y'all, f of x is just the same thing as y. So really what this is saying is that my x value is equal to 5 and my y value is equal to 19. It's the same thing that this function is telling us. Function notation is just a more algebraic way of referring to y. Okay. So let's move on. Let's look at one that's maybe just a little bit more difficult. So example 2, we have f of x is equal to 4 to the x with x equal to 3. So we want to evaluate it at 3. So f of 3 is equal to 4 to the third. Okay. Now I know that 4 to the third is 64 because taking something to the third means to cube it, which means to multiply it 3 times. So 4 times 4 is 16. And 16 times 4 is 64. Now, if you don't know that, you can use your calculator. And even if you don't have the TI, you can use a scientific calculator or your iPhone or whatever else you have. So you can do 4 times 4 times 4, because we know that's what it means to cube something, to multiply it 3 times. Or we can do 4 to the third, which gives us that 64. So f of 3 is equal to 64. And since we have that f of x term by itself, we are done. And remember, this does mean the same thing as x is equal to 3, y is equal to 64. All right, let's do one last one that's maybe a little bit more difficult. So we have example 3, f of x is equal to 2x squared plus 4x minus 5, and x is equal to negative 2. So for this one, okay, we're still going to replace x with negative 2. But notice we have multiple x's in this one. Well, we have to replace all x's in the function with a specified value. So every x gets replaced with negative 2. So 2 parentheses negative 2 squared plus 4 parentheses negative 2 minus 5. So let's simplify from there. So parentheses, then exponent. So we're going to square that negative 2. Negative 2 times negative 2 is positive 4. We can also check this by doing negative 2 squared, like so. And we also get positive 4. So 2 times 4 plus 4 times -2 minus 5, and that's still equal to f of -2. 2 times 4 is 8, so f of -2 is equal to 8. 4 times -2 is -8 minus 5. Well, 8 and -8 are going to cancel each other out, so we get f of -2 is equal to -5. And once again, we got that f of x term by itself, so we are done. And this still does mean that x is equal to -2 and y is equal to -5. All right, let's switch gears just a little bit. So now, in example 4, 5, and 6, instead of saying, giving you an x value, I'm saying find f of -6 or find f of 0. Okay, well, all that means is, see how I've replaced the x here? That just means -6 is what we're going to be plugging in. Okay, so f of -6 is equal to 1/2 times -6 minus 1. Well, 1/2 times -6, what's half of -6? That's going to be -3. So f of -6 is equal to -3 minus 1. -3 minus 1 is equal to -4, because they are the same sign, so we add them together and keep the sign the same. So -1 plus 3 is 4, and then we keep it negative. All right, let's look at example 5. So example 5, we're finding f of 0. So we have 2 to the 0 plus 7. So that's a little weird. But if we remember from our exponent properties, what's anything to the 0 power equal to? Well, anything to the 0 power is equal to 1. So f of 0 is equal to 1 plus 7. And then 1 plus 7 would just be equal to positive 8 because the signs are the same. So we add them together and keep the sign the same. And just in case you don't believe me, we can go check on our calculator. So 2 to the 0 is equal to 1, because remember that exponent tells us how many times to multiply something. So if the exponent is 0, I'm not going to multiply 2 any times. It's just equal to 1. And that's anything to the 0 power is equal to 1. That's one of our exponent properties. All right. Last but not least, y'all, we got example 6, and it's that one with double x's. This is our quadratic equation. So f of 4 is equal to 4 squared minus 4 plus 13. So I replace both of the x's with the 4. So f of 4, not 14, f of 4 is equal to 4 squared is 16 because it's 4 times 4 minus 4, just distribute that negative to the 4, plus 13. So 16 minus 4 is 12. So we get f of 4 is equal to 12 plus 13. And then 12 plus 13 is 25. All right, so the biggest thing here, y'all, is just remembering to replace all of the x's with the value that we're trying to evaluate. Okay? Make sure you follow PEMDAS. PEMDAS is very important. You can, of course, type these entire equations into your calculator. If you got the TI-84, then it's going to make it really easy. So like this last one, for example, I could have typed in parentheses 4 squared minus parentheses 4 plus 13. And would have also given me 25. So you can, if you got the TI-84, it's going to make these questions really easy. If you don't, you might have to do a little bit more work by hand, but that's not too hard. All right, and that concludes our evaluating polynomials notes.